Hi everyone, and welcome back to the Python for Absolute Beginners series. In this episode, we're going to cover data types that can store collections of data. So in episode 2, we went over variables that store just one value. Whether it was a string, int, boolean, or whatever else, our variable only ever stored one value. There are many times in coding, however, that we find the need to have variables that store more than one value. For instance, what if you wanted a variable that could hold all of your friends' names in it? We'll need a variable that can store multiple values for that, and that's where we're going with today's episode. We have 4 types of data in Python that can store multiple values in it, and I'm going to go over each one. They all share similarities to some degree. The first one we have, and probably the most commonly used, is a list. A list can have duplicate values, it is ordered, and it is changeable. Changeable just means that we'll be able to update the values in the list whenever we want, and ordered means that the items have a defined order that will not change. A list would look something like this. We always denote a list by using the square brackets, and we separate list items by commas. In our example, we're storing 3 strings that each represent one fruit. Oranges are in the first spot, grapes in the second spot, and apples are in the third spot. We can add as many other things as we want to the list, but oranges will always be first, grapes will always be second, and apples will always be third. Unless, of course, we delete these values from the list or something. Another example of a list storing ints would look something like this. An extremely important aspect of lists is what's called indexing. Indexing means the ordering of the values. We say that the first element of every list starts at index 0. The next value is at index 1, the next is at index 2, and so forth. So in this case of a list that has oranges, grapes, and apples, we would say oranges are at index 0, grapes are at index 1, and apples are at index 2. This index number is super important because this is how we're going to be accessing and modifying data in our list. Next we have a tuple, and a tuple is almost identical to a list except there is one main difference. Values in a tuple cannot be changed. This means that we can't add, delete, or modify any values inside of a tuple. Aside from that, it operates very similarly to a list. We write it almost the exact same too, except instead of using square brackets, we just use parentheses or round brackets. So we would write a tuple like this. The same rules also apply as a list. We separate items by commas, and the items will be in the same order every single time. If we wanted a tuple of ints, we could have, for instance, 5, 3, 8, and 7 in a tuple. Just know that once we create these tuples, their values cannot be changed or modified in any way. Tuples have the same indexing as lists. The first value is at index 0, the next value is at index 1, and so forth. The next one we have is a set. Sets also share some similarities with lists and tuples, but are a bit different. Sets, unlike lists and tuples, are not ordered, meaning if I have a set that contains 3 items, those items are not always going to be in that same order. Another key thing about sets is that they are partially changeable. Existing values in a set cannot be modified, however, you can freely add and remove items from a set as you please. We write a set similarly to how we write lists and tuples, except we use squiggly brackets for sets. So just remember, a list is square brackets, tuples is parentheses, and set is squiggly brackets. Another important thing about sets is that duplicates are not allowed, meaning we can't have the same value twice. Let's take an example of a set that looks like this. Right now we see it in the order of 10, 20, 30, and 40. But because a set is unordered, it could be 20, 30, 10, 40, for example. Sets always print out in a random order. Imagine that lists and tuples, which are very similar structures, are like people in a single file line. Everyone is in a particular spot and that order will never change. Sets, however, are like a room full of people that are constantly moving around. There's no order, so anyone could be anywhere in the room at any given time. In terms of how these data types relate to each other, lists and tuples are like fraternal twins, and sets are like that third sibling that don't quite fit in with the other two. If we have 2 fraternal twins and 1 misfit sibling, this last data type is like the distant cousin. Dictionaries are the 4th type, and they're very different from the other 3, yet also the most unique. Dictionaries, rather than just storing data on their own, use what are called key-value pairs. A dictionary would look something like this. Notice that we use squiggly brackets for dictionaries, just like we do for sets. One key-value pair from this dictionary would be brand Chevrolet, displayed like this. Brand is the key, and Chevrolet is the value. We always denote a key-value pair by writing whatever a key is, then a colon, then whatever the value is. A key is basically telling us what kind of value it is storing. If we have a key name brand, and we're specifically talking about cars, you can probably assume the value associated with it is going to be some sort of car brand. Similarly, if we have a key value pair where the key is name, we know the value associated with it is going to be someone's name. A key has to be a string, but a value can be of any type. Notice in the above example that all of the keys are surrounded by quotes because they are strings. Some of the values, like Chevrolet and Malibu, are surrounded in quotes because they're strings, but for instance, we can have an int like 2008 as a value too. So we're not limited to just strings in the value fields. We separate key value pairs by commas, just like we would separate list items by commas. Dictionaries are ordered, just like lists and tuples, meaning key value pairs will always appear in the same order. Dictionaries, also like lists, can easily be changed and modified as we please. Dictionaries do not allow duplicates. You can almost think of dictionaries like tables, like this. Dictionaries are used pretty often, and they're very useful in a lot of different scenarios. So now that we've gone over the 4 collection data types, I want to show this graphic here, just so you can visualize the similarities and differences between all these different collection types. Lists are ordered, changeable, allow duplicates, and we write them by using square brackets. Tuples are ordered, unchangeable, allow duplicates, and you write them by using parentheses or round brackets. Remember, lists and tuples are almost identical except for the fact that tuples cannot be modified at all. Sets are unordered, partially changeable, don't allow duplicates, and we write them by using squiggly brackets. Dictionaries are ordered, changeable, do not allow duplicates, and just like sets, we write them by using squiggly brackets. The way we differentiate dictionaries from sets is that dictionaries use key value pairs and sets do not. So we've talked about what each data type is, so now let's actually code them. Let's go in order of how I presented them, so let's start with lists and tuples. Because lists and tuples are almost identical, I'm just going to cover both of them at the same time. So let's make a new variable, let's call it myvar, and let's make it equal to a list. So I'll make it equal to 1, 3, 5, 7, and 9. And notice how for a list we use square brackets and we separate each entry by a comma. Now because lists and tuples are ordered, we say every number has a certain index, which basically means the position that it is in. Every list and tuple starts with index 0 and just goes up from there. So in our case, at index 0 we have 1, at index 1 we have 3, at index 2 we have 5, at index 3 we have 7, and at index 4 we have 9. This index number is how we access data. So let's say we want to grab 5 from this list. What index is 5 in? Well, we have 0, 1, 2, so we know that 5 is in index 2. So if we want to access that, we write something like this. So square brackets are always going to be what we use to access list and tuple values. And inside of those square brackets, we always put an index number. So this statement is basically saying, hey, let's look at myvar, which is a list, and then let's look at whatever is in index 2. And let's actually wrap this in a print statement here so you can see. And if I run it, index 2 should output 5. Yep, so if we run it, you'll see we get 5. So what if I want to grab a different number? Let's say I want to print out this 3. So what index is 3 in? Well, 3 is in index 0 and 1. So we know 3 is in the first index. So let's, instead of printing myvar index 2, let's print myvar index 1, and it should output 3. So note that in this list, we only have indexes 0, 1, 2, 3, and 4. So if I try to access index 5, I'm actually going to get an error because it doesn't exist. So if I try and do this, index 5, this error is going to say list index out of range. And that literally means I'm trying to access part of a list that doesn't actually exist. So if I just want to print the entire list out, say, let's clear this output here. If I want to print the entire list out, I would just remove this square bracket here. And just like any other variable, I would just type print and then the variable name, run it, and you see it prints out the entire list. Let's say I want to change a value in this list. Let's say I want to change this 3 to a 6. To do that, we'll need to know the index that it's at. Well, we already said we know that 3 is at index 1. So let's write it like this. I'll make a space here. So if we want to modify a value, we'll use the same square brackets I already showed you. So we write myvar at index 1 equals 6. Now this statement is basically saying store the value 6 at the first index of my var. So now if we run this, which is going to print out the entire list, you'll see we now have 1, 6, 5, 7, and 9. Let's say I want to change this 7 to a 15. So we'll do my var. We know that 7 is at index 3, so we'll do my var at index 3 equals 15. And now if print it out again, you'll see that 7 has now been replaced by 15. What if we wanted to add and remove values from a list completely? To add values, we use the .append method. So let's say we want to add 17 to the end of our list. So let me make a space here. And to do that, we're going to write the name of our list, .append, and then put parentheses. And then whatever value you want to add to the list, you put inside the parentheses here. So we're going to add 17. And now, if we run all this code, which is going to change this 3 to a 6, it's going to change the 7 to a 15, and then it's going to add a 17 at the very end. So if we print it out, you can see it did just that. What if we instead want to add a new item to somewhere else in the list that isn't at the very end? For that, we can use the insert method. So the insert method has two values that you need to put inside of it. The first one is the index you want to insert at, and the second one is the value that you actually want to insert. So let's say I wanted to insert the integer 3 at index 2. I'll make another space here, and I would just write my var dot insert. And then like I said, the first value should be the index we want to access. So we said we want to go to index 2, and then we want to insert the value 3. So now if we print this out, you'll see that at index 2, it just added a 3 and it pushed everything else over. What if we want to remove a value from a list? It's super similar to append, except instead of writing append, we write pop. So let's say we actually don't want this 17 at the end of our list anymore. So let's write myvar.pop. So after all these statements, I'm gonna make more space, scroll down a little bit so you guys can see a little better. We write myvar.pop, and then make sure to add parentheses. If you write it like this and don't put any number inside of these parentheses, it'll automatically remove the very last item on the list. So if we run this statement, you'll see, bam, the 17 is now gone. So we can actually specify a specific index with pop if we don't want to remove only the last item. So let's say we want to remove this 6. Well, we know this 6 is at index 1 because we have 0 and then 1. So let's say we just pop whatever's at index 1, and now we print it, and the 6 is gone. We've covered a ton of information about list in the last couple of minutes. Let me summarize everything so you can get a more clear and concise picture. So I'm going to go ahead and delete all of this here. I'm going to make some comments here. So to make a list, we write whatever we want our list name to be. Let's say my list. We write equals, then do square brackets, and can insert whatever we want inside of here, separated by commas. The index of a list represents the position. The first item of the list is always at index 0, and we just go up from there. So we have index 0, index 1, index 2, and index 3. To access a list item, write the name of the list variable, in this case, my list, then square brackets, and then whatever index you want to access. So if we want to access 5, this is at index 1, so we write it something like this. To update a list item, write the name of the variable, so we'll write my list, then square brackets of whatever index you want to use, so we'll say 2, and then set it equal to whatever value you want to update it with. So let's say 10. So in this case, index 2 represents 7, so we're replacing 7 with 10. To add an item to a list, we would just write the name of our list, dot append, and then add whatever value you want to add inside the parentheses. So let's say we want to add 3. Next, to add an item to a list at a specific index, we use the insert method. So we would write my list dot insert parentheses, and then the first value is the index we want to insert at, and the second value is the value that we actually want to insert. So let's say at index 1, we want to insert the value 40. To remove an item from end of the list, we would use the .pop method. So in this case, we would write my list dot pop, and that will remove the last element of the list. To remove an item from anywhere in the list, so to remove an item from anywhere in the list, we would use the .pop operator, except we would put whatever index we were to remove at. So let's say we were to move the value at index 2, we would write mylist.pop, and in parentheses we'd put 2. I know so far this is a ton of information all at once, so feel free to come back to this video whenever you need to use it as a reference. I'll also drop a few links in the description that basically have all this information that I just mentioned. We're going to be using lists all the time, so there's a good chance you'll see lists being used in the coming videos as well. Tuples are going to be pretty much the exact same as lists, except you don't have access to these append, insert, and pop methods. You also can't update any tuple values, and that's because we mentioned earlier that tuples are unchangeable. The only difference in how you make them is using parentheses instead of square brackets. Let's make a tuple now so I can show you what I mean. So let's go ahead and add another code block underneath this one. And let's write a new tuple. Let's say my tuple, let me scroll down here. My tuple equals parentheses, yes, comma, no, comma, maybe. Oops. So I can still print out and access tuple values just as I can with lists, like this. If I write print, and then we do the tuple name, so we do my tuple at index, let's say index 1. And if I print it out, it should print out no, because no is at index 1. But if I try and update it in any way, so let's say we try and update this. Let's say we do my tuple at index 1 equals LOL. And I try and run it, I'm actually going to get an error here. It'll say tuple object does not support item assignment because you literally cannot assign anything in a tuple. So if I try and use another function like append, let's say we use append, which obviously we can use with list. Let's say for a tuple, I try and do dot append. Let's just add haha on the end. Try and run that. I'm also going to get an error saying there is no attribute append because it basically doesn't recognize this method at all because we can't add or remove anything from a tuple. So tuple values can never be changed or modified in any way. So hopefully now you should have a pretty strong understanding of how lists and tuples work. So now I'm actually going to delete this code chunk here, and I'm going to make a new one, scroll down to it, and now I want to cover set. We said that you initialize sets by using squiggly brackets, so let's make a new set containing some strings of fruits. So we'll make a new variable, mySet, and set it equal to just some fruits here. Say bananas, we'll say grapes, and then we'll say apples, and then let's say oranges. And if you remember, one of the main rules of sets is that they are unordered. So if I actually take my set and I print out the whole thing, you'll see that it's not necessarily going to print in the same order that I initialize it in. So you see when I print it, it goes apples, oranges, bananas, grapes, which is a completely random order. And if I run it over and over again, it's going to print in the same order each time in this case, but just know that this ordering is kind of happening behind the scenes, and that like with lists and tuples, if we were to print it out, it would print exactly in order, but because it's a set and it's not ordered, this is going to be just kind of randomized almost. Because of this unordered aspect, we actually can't use square brackets to access individual values in a set. Another thing to note about sets is that they are partially changeable. When I say partially changeable, I mean that you can add and remove values from a set, but you can't update existing values. So for instance, I can add cherries or blueberries and whatnot to the set. So if I wanted to, I could also remove these values from the set once I felt like it. But I couldn't change one fruit, say from oranges to pineapple, because sets don't allow you to update or modify existing values. To add values in a set, we use the .add method. So if we wanted to add, let's just say a number, 25 to this set, we would write something like this. We would write mySet.add, and then inside parentheses, we would print 25. And if we run this, which will print out the entire set, you'll see it'll say, or it'll now have 25 in it, although again, the order is randomized, but we still added 25. If we want to remove an item from a set, we use the .remove method. You can actually use .pop to remove set items, just like we could with lists, but because the set is unordered, it's going to remove a random element, which usually isn't what we want. So to remove something, we would write .remove, like this. So let's say we decided we actually don't want this 25 anymore, so we'd write myset.remove, and then inside of the parentheses, we would put 25. And if we run this now and print out the entire set, you'll see that 25 is now gone. Because you can't access any individual set elements by themselves, the only way to access them is by iterating through the entire set or iterating through every single item. So we can iterate through all items of a list and tuple as well. That's a whole other topic though that we'll cover in the very next video. So just like we did with lists, let me summarize sets for you. So I'll make some space down here, clear this output, scroll down. So to make a set, we would use whatever we want our variable name to be. So in our case, we'll say like my set equals squiggly brackets, and then we can insert whatever we want here. Let's say 17, 25, and remember, set items are not indexed, so we can't access individual elements at all. So the only operations you need to know for now are add and remove. So to add to a set, we would just use the .add method. So let's say in my set, we want to add the value 32. So we do myset.add parentheses. Inside those parentheses, let's put 30. To remove an item, we use the .remove method. So let's say to remove item from set. And if you wanted to remove, let's say this 38, we would just write myset.remove 38. Like I mentioned, we could also use the .pop method with nothing inside the parentheses, but that's going to remove a random item, so that's probably not the best option. All right, and finally, last but not least, I'm going to open up a new code block here so we can cover the last data collection type, which is dictionaries. So dictionaries are super unique and have quite a few different applications in programming. I mentioned earlier that dictionaries use key value pairs. So let's make a new dictionary so I can show you how they work. So let's just name it my dictionary equals squiggly brackets, and then just follow along here. So I'm writing a key that is name, then a colon, and then inside the name, I'll just put Austin, and then the next key value pair you want, let's just say email, and then I'll just make up some email here. Let's just say austin@gmail.com, and then separate another comma for our last key value pair. Let's say we want phone, so I'll do that, then a colon, and then I'll just write some made up phone number like that. So this dictionary has 3 key value pairs. The first one is this, name, with a key of name and a value of Austin. The next one is this, with a key of email and a value of this made up email address. And the last one is this, with a key of phone and a made up phone number. So same as the other collection sets, we can also print out the entire dictionary if we want to. So let's do a print statement, and let's do my dictionary. Let's run it, and you'll see it prints out the entire dictionary. To access items in a dictionary, we can use square brackets, sort of similar to how we access list and tuple items. Except dictionaries aren't indexed, so instead of putting the index number inside the square brackets, we put whatever the key of whatever value we care about. So let's just say I want to grab this email right here. So to do that, I would write my dictionary, square brackets, and then write email. So what this is saying is, let's look at the my dictionary, actual dictionary, and then let's grab whatever value has the key of email. So if I wrap this here in a print statement, you'll see that it should output this made up email address here. And yep, it does print it out right here. Let's say I want to grab Austin from this dictionary. So to grab Austin, I would just put in name right here. And we print that out, and you'll see it'll say Austin. Keys always have to be strings, so you're always going to have quotations inside of the square brackets here. So to change items in a dictionary, we use this exact same syntax. So let's say I want to change this name to, instead of Austin, let's just say Jackson. So let me make some space here, and I would write my dictionary name, and then let's just change it to Jackson. And then if we print it out here, you'll see when it prints the name, it prints out Jackson because we updated it on this line. The super cool thing about dictionaries is that this is actually how we add elements too. So if I wanted to add a key value pair to my dictionary, I would simply put a key inside the square brackets that doesn't already exist. So let's add something. Let's just say my dictionary, let's add a new key called birth month, and let's set it equal to October. And I'm actually going to delete this line here just so we can output the entire dictionary. And if we run this, you'll see that as a scroll bar here, but it added a new key value pair at the very end of it with just birth month and October. To remove an item from a dictionary, we would just use the .pop method. And inside the parentheses, we'll just put the key of the key value pair that we want to delete. So let's say I no longer want to have this entire email field here. So let's make some space. I would write my dictionary.pop, and then inside of the parentheses, I would just put email. And now if we print out the entire dictionary, you'll see that the email field is now removed. Let's say I also wanted to get rid of the birth month field. I would just do the exact same thing. So let's do my dictionary.pop, and then we'll pop off birth month. And now if you print it out, you'll see birth month is gone too, and now we just have name and phone left. Dictionaries have tons of use cases in Python, so I'd strongly recommend getting familiar with them. So since we went over these couple of things, let's quickly summarize. So I'll make some space down here, and let's write to create a dictionary. We would just write our variable name. In this case, we'll just do my dictionary, equals sign, squiggly brackets, and then insert as many key value pairs as we want. So let's just make one that says name, colon, let's just say George, and then use a comma to separate different key value pairs. And then we'll say email, and then we'll just do LOL. So to type a key value pair, we write a key that will always be a string, so it's surrounded by quotations, and then colon, and then whatever we want our value to be. And then we separate different key value pairs by a comma. So next, to access items, so to access dictionary items, let me actually just clear this output here, we would use square brackets like this. So let's say we want to access this value George from this dictionary. We would write my dictionary, square brackets, and then the key of whatever is associated with that value. So we write name. To update items in a dictionary, we use the exact same syntax, except we can assign it a new value. So to update dictionary items, let's say we want to update the name that we just accessed. We would say my dictionary name. Let's just change it to insert name here. And that's how we update a value in a dictionary. To add items to a dictionary, go ahead and scroll down here. We just use the square brackets again, except we make sure that whatever we're putting inside the brackets is something that doesn't already exist. So let's just say we want to add a new field that says birthday, and then we'll just add in a month, let's say October. To remove items from a dictionary, so to remove items from dictionary, we use the .pop method and insert the key of whatever key value pair we want to remove. So let's say we want to remove the email field from this dictionary. We would write my dictionary.pop, parentheses, and then we would type in email. So in this video, we covered the 4 data types that can store collections of data. You learned about lists, tuples, sets, and dictionaries. For lists, you learn how to make one, access values, update values, add values, and remove values. For tuples, you learn the exact same things minus updating values since you can't do that with tuples. For sets, you learn how to make them, how to add values to a set, and how to remove values from a set. And lastly, for dictionaries, you learned what key value pairs are, how to make a dictionary, how to access certain key value pairs, how to update values, how to add values, and how to remove values. So in this video, we covered a huge amount of information, so don't be discouraged if it doesn't all click right away. I'd highly recommend hopping into Google Colab and messing around with these different collection data types. The best way to fully understand these data types is just through trial and error, and it may take a bit of time. I'd also highly recommend, if you're struggling or forgetting how to do certain operations, to refer back to this video if you need help. Like I mentioned before, I'm also going to link a few resources in the description so that you can use these to help guide you through your learning journey. Next video will cover something incredibly important, which are loops. Take care, and I'll see you next video.